Hi Level 2s, this is the second lesson in the motion series. So we're going to look at graphs of motion in particular here. So you might remember from last year we looked at displacement time, velocity time, acceleration time graphs. So a displacement time graph has always got displacement on the y-axis and time on the x-axis. So if a person walks forward at 3 meters in a time of 3 seconds. I should really have the scale on here, but we'll assume 1 square is 1 second, and 1 square on this end on the y-axis is 1 meter. Then they stand still for 3 seconds and immediately turn around instantaneously and walk back to where they started, but they do so slowly, so it takes them 6 seconds. What you will notice is that the gradients for this portion and the latter portion are different. So this is quite a steep gradient in comparison to that, which means that the gradient of the graph will give the velocity. Okay. We also remember that to calculate the gradient of a graph, we find the change in rise over the change in run, so the change in y over here over the change in x, and that will give us the velocity from a displacement time graph. So velocity, you've just seen this equation in the previous lesson, is the change in displacement over change in time. So velocity time graph has velocity on the y-axis and time on the x-axis, and you can see that this corresponds to the previous graph. So that if I draw or put them both on one screen, you can see that that velocity, which is the gradient on the displacement time, is a positive value on the velocity time axis, velocity time graph, whereas this one has 0 gradient, so that's 0 velocity, and the third portion is a negative gradient, and it is less than this gradient here, lower value, and so it will be closer to the x-axis in the negative area of velocity. So we can correspondingly draw one graph from the other. Another thing you might want to notice is that you could draw displacement from the velocity time graph. Any idea how? Want to have a think? Yes, so you might have guessed that the area under the velocity time graph, the area, so that is the change in velocity times by the time, will give you the displacement on the displacement time graph. Right, next thing to look at is that the gradient of a velocity time graph gives the what? Pause and think. It gives the acceleration of the object. So this, that's been chopped off, but it says the straight line represents constant acceleration. There it is at the bottom of the next screen. So the acceleration is equal to the change in velocity divided by the change in time. So let's take a look at this graph. There are some numbers on here. So if we wanted to work out the acceleration from this graph, it's a VT graph, then we can work out the change in velocity over the change in time. So what is the change in velocity here? It's 7 take away 2. So remember, if you're going to work out values from a graph, please draw the rise over run. So you need to draw the triangle on the graph. So 7 take away 2 over 10 take away 0, which is 10. And you're going to get 0.5 meters per second squared. What does the area under the velocity time graph give us? We've already said that, the total displacement of the object. Okay, so distance traveled from this graph, we can work it out, will be the 2 times 14 plus we've got to work out this little triangle at the bottom here, which is a half, 2 times 14 is this portion here, and then the triangle is the half base times height, which is half 14 times 5 for that triangle portion there. Please note the reason for this is because we started at an initial velocity of 2, and we get the total distance traveled at 63 meters. Here's an example. Draw a velocity time graph for a car, initially moving at a constant velocity of 20 meters per second for 3 seconds, and then it decelerates at a rate of 2.5 meters per second. At what time is the car at rest? Calculate the total displacement of the car from your graph. So for the first 3 seconds, there's time on the x-axis, and the 3 is the first number there, and then it decelerates at that rate, 2.5 meters per second. So for the first portion, we can then work out the total displacement, which is the 3 times 20. We can then add the triangle area, which is the half base times height, so it's a half 11 minus 3 times by 20, which is the height, and you find a value of 140 meters. Could you now go over the examples on those pages? So that will be examples on page 97 and the top of 98, and then complete this task on graphs of motion, activity 8b. We'll do these in class.